On to geometric proofs. This is a little more complicated because we have a lot of theorems and postulates and a lot of things that we need to know that sometimes it's easy to forget. So the first thing, you should have a colored paper that has common theorems and postulates on it to kind of help guide you through this process. So in this example, we have this picture right here, and we are given that the measure of angle 1 is equal to the measure of angle 3. So that's what this cute little line right here means. It means that these two things are equal to each other. And we want to prove that the measure of angle EBA, which is this angle right here, is equal to the measure of angle CBD, which is this guy right here. Okay, so we want to prove that this pink angle and this purple angle are equal in measure. And so far, all we know is that angles 1 and 3 are equal in measure. So, first statement is always given to us. So a measure of angle 1 is equal to the measure of angle 3. The reason for that is given. Awesome. You guys should all get this every time. The first reason is always given. Next, we have that the measure of angle EBA is equal to the measure of angle 2, which is this middle angle right here, plus the measure of angle 3. So the measure of angle EBA, the pink angle, is equal to the measure of the middle angle plus the measure of the angle on the right. Now, we know this because of the angle addition postulate, which, if you look at your paper, tells us that if you have two angles and you add those two angles together, then the measure of your new angle is going to be equal to the measure of your first angle plus the measure of your second angle. So we use the angle addition postulate here. I'll give you a second to write that down. Okay, perfect. So angle addition postulate. Now we want to say that the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. So we want to say that the measure of this pink angle right here is equal to the measure of our middle angle plus the measure of the angle on the left. Now, we can say that because angle 1 and angle 3 are equal in measure. The property we're using here is called the transitive property. The transitive property is a really cool little property. It tells us that if we have, here, you have it on your paper, but I'm going to go ahead and write it here. So the transitive property states that if A equals B and B equals C, then A equals C. And what that basically means is if I have 5 $1 bills, I can take it to the bank and I can get 20 quarters, right? 5 $1 bills. Well, let's do this with 10. So if I have 10 $1 bills, I can take it to the bank and I can get 2 5s, right? If I have 2 5s, I can take that to the bank and I can get a 10. But I can also take my 10 $1 bills and exchange it for one $10 bill. So it's basically saying that if these two things are equal and this is also equal to something else, then the first thing and the last thing have to be equal. Hopefully that kind of makes sense. If not, go ahead and write it in the questions part that's going to come up in a couple slides. And we can get more on that. So by the transitive property, we know that the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1. Now we have that the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle CBD. So the one on the left plus the one in the middle is equal to the measure of the purple angle. We know that because of the angle addition postulate. And because the measure of angle EBA is equal to the measure of angle 2 plus the measure of angle 1, and the measure of angle 2 plus the measure of angle 1 is equal to the measure of angle CBD, we can then use the transitive property to conclude that the measure of angle EBA is equal to the measure of angle CBD. Now on the next slide, I want you to give me a fist of 5. And then on the slide after that, give me any questions you have on this first example.